Okay, so first things first, we're going to be using this formula. And let's go ahead and start by plugging it in. So the heat of the calorimeter is equal to the heat capacity of the calorimeter times the change in temperature. So here it's saying that the temperature rises from 24 to 25 degrees Celsius to 32.33 degrees Celsius. So a change in temperature is equal to the temperature final minus the temperature initial. Let's go ahead and solve for the change in temperature. And that's going to give us 8.08. And then it's given that the heat capacity of the bomb calorimeter determined in a separate experiment is 5.11 kilojoules per degree Celsius. So I'm just going to plug it in. And then I'm going to cancel out the Celsius. And we're going to go ahead and just multiply. It's going to give us 41.3 kilojoules. And there's another formula that we need to know. It's that the heat of the reaction is equal to the negative heat within the calorimeter. So the heat of the reaction is going to be negative 41.3 kilojoules. And the reason why it's negative is because it's a combustion reaction. In combustion reactions, the heat of the reaction is always going to be negative because it's giving off heat. So moving on, we're going to need to convert 1.025 grams into moles. And we have the formula here. So C10 plus H10. So carbon has a molar mass of around 12. 12 times 10 is 120. Hydrogen has a molar mass of around 1. 1 times 8 is 8. We have 128 grams per mole for hydrocarbon naphthalene. All right, so let's go ahead and do stoichiometry to convert the amount of grams into moles. That's going to give us 8.01 times 10 to the negative 3 moles C10H8. And now it's asking us to find the change in enthalpy for the reaction. So we're just going to divide negative 41.3 kilojoules by the amount in moles. And I look at the units to help me find out that I need to divide by kilojoules over moles. That's going to give me negative 5.16 times 10 to the 3 kilojoules per mole. That right there is my answer. Thanks for watching.